Today we'll be discussing shear reinforcement. But let's check first, ano ba yung shear reinforcement na meron dun sa structure natin? So for example, meron tayong simply supported beam. And it is subjected to, let's say, a uniform load. Let's say it has both live load and dead load. So obviously, we'll be computing for the ultimate uniform load. And that is 1.2 of the dead load plus 1.6 of your live load. So as you can see, if we cut the member, let's draw its free body diagram. It will surely have both moment and shear. So ibig sabihin, yung beam natin in this case is subjected not only for moment but also for shear. Therefore, magkakaroon tayo ng shear stresses. Now, because of that, we need to also consider ano yung ginagawa ng shear natin dun sa structure. So again, let's have this uniform load W. Then, let's draw its equivalent shear diagram. So in this case, we'll be having a maximum shear on both ends of the beam. Then we will be having somewhat na ganito yung magiging value natin. In this case, this will be your maximum moment. And also on this side. However, if we will be considering shear failures, let's say this is your shear. And this is, let's say, your longitudinal or main reinforcing steel bar. Okay? If there is a force P here, and we have here your support, let's say this is your face of the support, crack actually occurs at 45 degrees. So based on the code, yung crack natin ay nag-occur 45 degrees. Now, if this is what we call the effective depth or the D distance, obviously, this distance is also the effective depth D. So in that case, yung failure pala natin is actually occurring D distance from the face of the support. That's why in this drawing or in this diagram, we will be considering your ultimate shear at a D distance from the face of the support, and that will become your VU. And we all know that the actual load must always be less than or equal to the resistance load. In that case, we have your VU must be less than or equal to the resistance factor, or what we called the strength reduction factor, multiplied by the capacity. So in this case, this is actually phi multiplied by Vn. Or we can say that Vu is less than or equal to phi multiplied by Vn. So if we are designing, obviously, to make our design economical, to determine the nominal shear capacity, it is just equal to Vu over phi. For shear, the reduction factor is 0.75 for 2010 and 2015 code provisions. Now, sabi natin Vn is the nominal shear capacity. Okay? As we all know, the concrete or yung concrete structure natin can resist shear. So therefore, it has what we call the shear capacity, or what we call the concrete shear capacity. Okay? In any case that the load exceeds the concrete capacity or the shear concrete capacity, obviously, doon papasok yung tulong, which is the shear reinforcement. That's why we need to identify first, ano ba yung capacity ng VC? Para ma-identify natin, ilan ba yung kailangan niyang tulong? Ilan ba yung reinforcement na kailangan natin i-provide? So in this case, ano-ano ba yung mga formula natin ng VC? So let's enumerate. For shear reinforcement, based on both ACI and NSCP 2010 and 2015, the formula for shear is divided into two. We have the simplified and the detailed calculations. So what is simplified calculation? So the shear capacity of the concrete is just equal to 0.17 of lambda multiplied by the square root of FC prime BWD. So your lambda is your modification factor in which your lambda is equal to 0.75 for lightweight concrete it is equal to 0.85 for sand lightweight and it is equal to 1.0 for normal weight. And we have here your FC prime. We all know that FC prime is your specified compressive strength of concrete. Your BW as the breadth, or let's say the width of the concrete section, and D is your effective depth. However, this formula is only applicable if it is only subjected for both shear and flexure only. So what if your concrete beam is now subjected to shear plus flexure plus axial compression or compressive force? Okay. Your VC or your shear concrete capacity is now equal to 0.17 multiplied by 1 plus NU over 14 AG multiplied by its area, which is BWD. Okay, so where NU is your ultimate compressive force. And AG is just your gross cross-sectional area. Now, let's now have the detailed calculations. So, if it is only subjected to shear plus flexure only, the formula will be VC equals 0.17 lambda, which is your modification factor, multiplied by FC prime plus 17 raw W multiplied by VU D over MU, then multiplied by its area. So as you can see, there is an additional term. If you will be kung ikukumpara mo siya or if you will be comparing it from the simplified calculation na una natin diniscuss, nadagdagan tayo dito ng itong term na to. No? Okay? Your raw W here is just your steel reinforcement ratio. So it's very same. It's AS BWD. There is a subscript W to show that if there will be or if you will be given a T-section, you will just be using the width or the breadth of the web member and not the whole flange member. Okay? And then we have your MU, which is your ultimate moment. Now, why do you think in detailed calculations, they also consider the moment? Like what we have said yung kanina sa discussion natin, your concrete beam or your concrete structural member is subjected to both forces, shear and moment. So, it's better to consider both forces acting on the structure. Now, in this case, we have also the formula if it is subjected to shear plus flexure plus axial compression again. And the formula is just equal to VC. It's very same. 0.17 of lambda square root of FC prime plus 17 rho W multiplied by VUD, but rather than using MU, it is substituted with MM multiplied by BWD, where MM is just equal to your original na ultimate moment minus the ultimate axial compressive force multiplied by 4H minus D over 8. Okay? And again, in this formula, let's go back here. Okay? This ratio must always be less than or equal to 1. This ratio only. Why? Because if the ratio between VUD over MU is greater than 1, so parang mo na rin sinabi na yung moment na nag-a-act dun sa structure natin is so small na halos hindi na natin kailangan or halos hindi na pala siya nakaka-apekto dun sa structure. That's why it's very important in a detailed calculation that the ratio of VUD over MU must be less than or equal to 1.0. So those are the formula that we need to consider to determine the value of VC. Now, after determining the value of VC, remember we have here your nominal moment, nominal shear capacity, which is equal to VC plus VS. So in designing, we all now have the value of VU, or VN rather, based on VU. Then we now computed for the value of VC, which is the shear capacity of the concrete. So in any case that VN is greater than VC, doon papasok na kailangan natin ng reinforcement, and that is your VS. So that's why this is your shear reinforcement. Now, for example, again, have here again your beam section. Okay. Then we have here your shear diagram. Like we have said, this is your VU. Okay? We are computing for the spacing of the stirrups or your web reinforcement for every D section or D distance. So D distance, then another D distance. So let's say this is VU1, this is VU2. Now, we need to determine how many stirrups ang kailangan nating ilagay for every D distance. Paano natin yun malalaman? For example, if this is your section, and you need to, let's say, that your stirrups or your web reinforcements must be in U shape. Okay. We have here what we called AV, or the area of shear reinforcement. How to determine AV? It's just actually by passing through a cutting plane, and you will just check ilan yung stirrups na nadaanan natin. So that is 1 and 2. So meaning AV is just actually the area of a single stirrup, in that case the area of a circle, multiplied by the diameter of the transverse reinforcement or stirrups squared. Then dahil nagpass ka ng cutting plane and dalawa yung stirrups na nadaanan mo, AV must be multiplied by 2. Okay, now the question is, we'll go back to the question, how many stirrups or transverse reinforcements ang kailangan nating ilagay for every d distance? Let's go back on your mechanics of deformable bodies. We all know that we have, or we can say that stress is equal to force over area. In this case, your force here is your Vs. Your AV here is your area. Okay? And the stress is obviously FYT, or what we call the yield strength of the, kaya letter T yan, it means transverse reinforcement, which is actually your shear reinforcement. So in that case, we can say that force, or Vs, is just equal to the stress, which is FYT, multiplied by AV. But we need to also determine, sabi natin, ilan ba yung reinforcement sa isang given na distance D. So paano natin malalaman yon? For example, I have a D distance. And let's say I need 3 stirrups. Okay? So we have 4. 1, 2, 3, and 4. So sa tingin nyo, paano kung malalaman kung ilan yung stirrups? It is actually the same as having the spacing of the stirrups, in which N here, or the number of stirrups, is just actually determined using the total distance D divided by the number of spacing. So that is divided by S. So in this case, Vs is just actually FYT plus, multiplied by AV multiplied by T over S. Or we can say that the spacing is just equal to AV FYT D over Vs. So this is how we determine the spacing of the stirrups. Gaano ba kalawak yung distance ng bawat stirrups sa bawat isa sa everyday distance. Ngayon, kung makikita nyo, yung shear diagram natin is actually decreasing mula sa end papunta sa gitna, then pa-increase ulit. So do you think, ano yung meron dun sa stirrups natin mula sa pinakang gilid hanggang sa pinakang gitna? Dahil paliit ng paliit yung VU natin, paliit din ng paliit yung VN ko. Since VC is constant, kung lumiliit yung VN ko, lumiliit din yung VS. In that case, kapag malapit pala sa face ng support yung stirrups or yung force na kino-consider natin, masiksik pa yung mga stirrups natin. Habang papunta tayo ng papunta sa gitna, lumalaki yung spacing natin. Because as you can see, the spacing is inversely proportional to the shear force, or the shear carried by the steel reinforcement. So these are the formula that we need to consider. However, we need to also consider the what if your required force or shear force is less than the shear capacity. Does it necessarily mean na hindi na natin kailangan ng reinforcement? Kasi sabi natin kanina, yung required shear force is greater than sa kaya lang ng concrete natin. Kaya naglalagay tayo ng additional na reinforcement. So what if yung required shear force or yung actual load natin is mas maliit naman kaysa sa capacity ng concrete? Does it necessarily mean na hindi na natin kailangan ng maglagay ng stirrups? Obviously, we need to consider the code provisions, in which the code states that if VU is less than or equal to 0.5 of phi VC, no reinforcement is required. However, if exceeds the value of 0.5 of phi VC, that is, we will be using the minimum reinforcement. So these are the formulas that we need to consider. So let's also consider the formula for the maximum spacing of transverse reinforcement. So the maximum spacing of transverse reinforcement is 600 millimeters, or the effective depth divided by 2, whichever is the smaller value or the smallest among the two. However, if the computed VS is greater than 0.33 square root of FC prime BWD, this allowable spacing must be multiplied by 1/2 or divided by 2, which will become a smaller value. So yung 600 natin, it will become 300 millimeters or d over 4. Again, whichever is the smaller value or the smallest among the two. So these are what we require to remember when we are computing for shear reinforcement. Now, let's have an example. So for example again, you will be given a simply supported beam. Let's have here your supports. And again, a uniform load. Let's say the uniform load is already an ultimate load. Let's say this is 50 kilonewton per meter. And the distance of the beam is 10 meters. So in that case, we all know that the supports are, we have 50 times 10 divided by 2, that will give you 250 kilonewtons. So if we draw the shear diagram, that will give you a value of 250 kilonewtons. However, we need to determine VU, in which VU is actually the distance from the face of the support. So let's have the properties of the beam first. No? Let's say B, I have 300 millimeters. Then the effective depth D is, let's say, 450 millimeters. The total height is, let's say, 500 millimeters. Let's say it is reinforced with 20 millimeter diameter, and we have Fy to be, let's say, 400 MPa, and Fy for transverse is, let's say, 276. In practice, we are always using a smaller value of yield strength of the transverse reinforcement rather than, or unlike, a higher value of the yield strength of the main reinforcing steel bars. Okay, let's also have your FC prime. Let's say, let's use 21 megapascal. Okay, so how do we now compute for the value of VU? So we can use ratio and proportion, or we can actually form your shear diagram, or your shear equation rather. If we cut this section, let's say this is distance x, you can have your shear equation as V equals 250 minus 50 times x. So obviously, we will be using D as your 450, or in meters, that is 0.45 meters. So substituting D, if x equals d, which is 0.45 meters, v is, so we have that's 250 minus 50 times 0.45, so that will give you 227.5. Again, that is in kilonewtons, or that is just equal to 227.5 times 10 raised to 3 newtons. Again, these values are your VU. And since we are designing, we need to compute for the value of the nominal shear capacity. And sabi natin kanina, it's just your ultimate divided by the reduction factor. And for shear, again, the reduction factor is 0.75. So we have Vn, or your answer natin, times 1,000 divided by 0.75. So that will give you 333.33 newtons. And we all know that this is equal to Vc plus Vs. So what we need to do now is to compute for the shear capacity of the concrete. So how do we now compute for the shear capacity of the concrete? So let's use, let's say, simplified calculations. Again, for simplified calculations, Vc is just equal to 0.17 of lambda multiplied by square root of Fc prime BWD. So in this case, what are the given values or the parameters? Since it is not stated in the problem, we can assume that the concrete is of normal weight. Again, normal weight is, or has a modification factor of 1.0. Your BW here is just your B, which is 300 millimeters, and your effective depth is 450 millimeters. And obviously FC prime is 21. So we can now compute for the shear capacity of the concrete. In that case, that is 0.17 multiplied by 1 multiplied by square root of 21 multiplied by 300 times 450. So in that case, the shear capacity is only 105,170.11 newtons. In that case, we can now compute for the value of Vs, since Vn is just equal to Vc plus Vs. Therefore, we can say that Vs is, so that's 303,333.33 minus 105,170.11. Okay, then we have here your 198,163.22 newtons. And let's say, or let's assume that we will having this type of section. Let's assume first that your stirrups is just a U section. So in that case, if we pass again cutting plane, we have here 1 and 2. AV here is just equal to 2 multiplied by pi over 4. Let's say the diameter of the transverse reinforcement is, let's say, 12 millimeters. So I have here 12 squared. So AV is just equal to, so we have 144 divided by 4 times 2 times pi. So that will give you 72 pi, or 226.19 square millimeters. And as we all know, we have in kanina, the spacing is just equal to AV FYTD divided by VS. So, which gives you the spacing of, so we have here your AV, which is 226.19 multiplied by FYT, which is 276, multiplied by D, which is 450 divided by VS, in newtons, which is just 198,163.22. So as you can see, the spacing is 141.77 millimeters. Or, obviously, in construction, hindi naman tayo pwede maglagay ng spacing na may point something. So we are actually rounding off, or we are actually rounding off the spacing. Now, do you think we should round it up or round it down? So obviously, we need to round it down. So the answer must be 140 millimeters. If it tells you to round off in terms of, or in multiples of 10 millimeter. Okay? Now, why do you think we need to round it down always? Okay, hindi tayo pwede mag-round up. Why? If you round it up, you will be having a greater value of the spacing, which will give you a lesser value of the shear capacity. Because again, they are inversely proportional. In that case, hindi na natin kakayanin yung kailangan na strength. That's why we need to always round it down. Now, let's check. Okay? According to the code, we need to identify if it is greater than the maximum spacing. Okay, so what is the maximum spacing? So let's check first. Thus, our VS has a value greater than what we have written in our previous topic. 0.33 square root of FC prime BWD. So let's check. Okay. So sabi natin, VS is just 198,163.22 newtons. And what is the value of 0.33 square root of FC prime BWD? Okay, so that will give you 0.33 multiplied by the square root of FC prime. In this case, that is 21. Multiplied by BW, that's 300 times 450. Okay, so we have here 4,153.75 newtons. And as you can see, VS is less than 0.33 square root of FC prime BWD. Therefore, the maximum spacings to be considered are only 600 millimeters or d over 2. In this case, d over 2 is just equal to 450 divided by 2. That will just give you 225. And as you can see, 140 is less than 225 millimeters. Therefore, we can use S, or use S equals 140 millimeters. So that is one of the simplified calculations on how to determine the shear reinforcement for a concrete beam.